Martin and I'm an aero modeller and an engineer. Join me on a fascinating journey where I show you some of the techniques used in scale aero modelling. So in this little video I'm going to have a go at turning a spinner backplate. We've got some quite large aluminium discs off eBay and they're fairly cheap. Got some fairly thick circular ones there in steel as well, just in case I needed to make a really heavy one. So I'm going to have a go with this disc here. Now the problem I've had in the past is how to attach this to some sort of mandrel or to hold it so that you can do the edges. Now what I've seen is you drill a hole through the middle of this, drill a hole through a mandrel, and then you bolt. You thread the mandrel and you put a bolt through the middle and you bolt the two together, and then that's enough. Right, should be a little bit better centered now. There we go. So all I'm going to do is drill a hole in the middle of that. Just a bit of cutting stuff. Now the diameter of the motor shaft on a Turnigy 4258 is 8mm. The bevels allow for the radius that's on the shaft. So we're good to go. So where's our mandrel? So what I ended up doing, rather than making a mandrel, I realised that I had the output or the propeller adapter for a 4258 motor. So I bolted that into the chuck and bolted the spinner backplate to that. So I've not tried the CA glue, this is purely friction. Let's see if we can turn the edge of this. Fingers crossed. And looking at the way it's cutting, it's horrible. So I can only assume that we're going too fast. way the disc has been punched out has left a really nasty edge. Right, we need to think about what diameter we're going to finally make this and what angle we need to put on it, what bevel. So that's the angle we're looking at. That's it. I'm sure all the engineers amongst you are cringing at the way I'm doing all this, of course. I just want to try the bevel, just see what we get. Much better. And as you can see, we're pretty close already. This is an old spinner. And the angle's about right. A couple more passes. Good job I didn't leave it too long. That was a very light cut, a finishing cut. Just see what that goes like. Oh, nearly there. Probably another half a mil. Okay, what you can see here is I've used that same prop adapter that was on the motor to clamp the disc as we did in the lathe, and I've clamped it into my, I don't know what you call it, cross slide in my milling machine. I know what angle I cut this bevel, 26 degrees, so I've set this to be 26 degrees plus 90 to get that angle so that I know I'm perpendicular to this flat edge. And then I've used a bit in my mill to drill these holes, and then I've used the vernier on the rotating table to give me 45-degree increments all the way around the circle. Now what I'm going to do is I'm going to back this off and I'm going to change the bit for a drill bit, and it's going to need to be the right size drill bit to give me a 2mm clearance hole, and I'm going to use a 2mm countersunk head countersunk screw to hold the spinner cone onto this. So next step, change this collet for probably a 2mm. If it's going to be a 2mm screw, it's probably going to be a 1.6mm clearance hole, but I'll look that up, change it over and do it. So I'll change the drill bit and we'll do some drilling. So the clearance drill for this is 1.5mm. So suitable drill bit is fitted into the collet of the mill. And I'm going to bore all the way through until I come out the back of the spinner. And there we go. To be honest, I'd already done that hole, so that's just replication. But what I'll show you now is moving this along 5, 10, 15, 20, 25, 30, 35, 40, 45. So we should be right on that hole, which I'd already done as a pilot. And we'll go right through to the other side of the back plate. I'm even going to drill into my chuck. I'm only going to go that far at this instant. because I don't want to drill into my chuck. 5, 10, 15, 20, 25, 30, 35, 40, 45. So that's all the holes drilled, ready for tapping. I've shown vac forming before, so I'm not going to go over that again right now. But needless to say, this is a hardwood plug that I made a couple of years ago. It was actually for a 1/6 scale Spitfire, and it just happened to be the same profile as my 1/6 scale Hurricane as well. So the version of Hurricane I did had the same spinner. So that was my vac forming tool, and this is made out of Meranti wood, and you can see it's lots of sections laminated together. Then a lathe backplate was put on the back, and it was put in my metalworking lathe. I know, sacrilege, but there you go. And then this was turned using a profile template. It was then vac formed in my oven using my vac form grill, and this was a spare cone that I had done. It just so happens that sections of this cone are the same profile as the Chipmunk. Curious, eh? So what I've done is I've placed my spinner back plate inside the cone, and then used sunlight shining in through the window, which you probably can't see on the video, to get it to sit perfectly aligned. And I've used a couple of lines created just by that and turning this disc. This gives me perfectly concentric lines that I can follow, and it just so happens when the disc is in and sat just above that pencil line, we're good to go. So what I'm going to do is just cut that off at that line there, and that should give us a good starting point. Now there's a couple of ways of doing this. If you've got a cutting disc in a drill, in a pillar drill, and you lock the height, say this is the cutting disc, you lock the height in the pillar drill to that, then you can move this disc against the cutting disc and cut right round, and that will cut it off for you. But it's just as easy in this case to use a pair of scissors, I think, because I've got a nice accurate line to follow. But if you didn't have a line and you just had the cone, you could stand it like this, put the cutting disc as high and low as you think is right, and spin it. But I'm going to cut this with a pair of scissors to that line. If you watched the carving a scale prop video that I did recently, this is the propeller, and it's now being balanced. It's actually come out, I've shaped it a little bit further than I did in the video, brought the hub down much smaller, made these blades much finer, and I think I'm much happier with that. It also, where the spinner comes in, it's going to give us a nice defined slot in the spinner cone. So, and I'm pretty pleased with that. By the time I've lacquered it or painted it black, it's going to alter the balance again, so I'm going to end up putting a slightly more coat of black on one blade than the other to get it right. But if the material, if the maple is about balanced, then the paint makes it fairly straightforward to balance. I've got the back plate, and we have the prop, and there we have the cone that's been vac formed. So the tricky job here is actually cutting the notches for the prop blade, and I hate doing this. There's no easy way to do it. You just seem to end up nibbling away, and I really hate it. So what I've also done is I put the cone on the now there's a mark on this. an arrow there and an arrow there. Now it shouldn't matter where it lines up, it shouldn't really matter at all. But what I did was I put the disc in place and I shone a light through these holes so that I could see where the drill holes need to be in the cone. So what I've got to do now is cut the cone. What I might try is taking a piece of the skirt and try and make the shape. I've got several chances of getting it right. Try and make the shape that fits that perfectly, because it is a similar sort of curvature to the spinner cone, to the backplate. So see if I can make the slot fairly accurately. I can always add bits of plastic to close the gaps, and then once I've got that as a template I can mark the proper one. Anyway, that's what I'm going to try and do. So what I ended up doing was cutting a curve for the top and making sure it fitted that. And then I cut another piece for the curve of the bottom, which actually is more as a straight line. Then take the two together, and that's given us quite a nice pattern for the prop cut out. What I need to do is pick an area between the screws, lay the prop on it, like lay the template on it, draw around it, and then it doesn't actually need the prop to do this. There's the cutout for that, and I'm going by the trailing edge, which is right on the tip. The cone is, two spinner sections are between the two, so the trailing edge, which is there on that one, there, draw around that. And with a bit of luck and the following wind, if I cut those out fairly accurately, we might get there. Failing that, of course, we may end up having to vac form another cone. And you can see, I think you can see this side is nice. Now you see the prop is moving nicely in the slot. I think what I need to do is bolt the prop to the back plate, so at least that can't move around. Well, after much fettling, it's done. I've got the lip at the bottom correct, and it all sits nice. I am disappointed in the cutouts and the notches. I had hoped for slightly better, but there we go. I'm waiting now for the screws. I've got some countersunk M2 screws coming that will go around the edges. The back plate is drilled, ready to accept the screws, and these are soft. These are tapped M2 with a 0.4mm pitch. So once those screws arrive, I'll drill these holes and fit it. In fact, I might drill these holes now anyway, but I can't do anything until the screws arrive. So here you can see I've drilled the holes around the outside, and I've used M2 screws, but these are not the correct countersunk ones that I will be using. These are just to prove that it works. So the next step is to take these out, take this off, put the prop on, and see if it still fits. Couldn't do that again if I tried. I had to put a lot more red on there than I expected because of the pen line that was all the way around the outside. I should have tried to sand that off or clean it off with some chemicals or something. My favourite bit of modelling is peeling off masking tape. In this case I didn't use masking tape, I used electrical tape, which is probably not a good idea. A bit too sticky. You can leave a residue, as long as you take it off straight away you should be okay. Fortunately I'm making a bit of a meal of finding the layers that I put on last. So that's the electrical tape off. Now let's just see if we can get the Tamiya tape off and see if we've got a really nice sharp line, which we should do. Lovely. That suits me just fine. And there we go. Our static prop has tips. So the way I'm going to do my static propeller is I'm going to join it all together with silicone. It's an aquarium sealant, King British aquarium sealant. Now the reason I like this is it doesn't seem to go solid in the tube, and I've bought silicone loads of times and 2 months later when you go back to use some it's solid. This is over a year old and it's still good. So what I would advise you to do is to get a smaller tube of this, not a big one, you know, that can go off before you get used to it, before you get around to it. So just buy a slightly smaller tube and just buy more of it, you know, if you need it. I use it all the time, I really do. So what I intend to do, this is a prop driver off of an electric motor, and it's the same size as the one I'm using, and I'm just going to use it as a guide. So what I'm going to do is I'm going to smear silicone on all the parts so I can get it all apart again should I really want to. But the idea is that this will sort of stay semi-assembled indefinitely, and what I want to be able to do is to screw the prop onto the motor shaft without having to take the cone off. So what I'm doing now is I'm just looking for the lines on the back plate tell me where the trailing edge of the blade is. So that should be good. I have to put silicone on the nut. Now the problem is I don't really want to get it on the thread, but I don't think it'll matter too much because when I undo the back bit, hopefully this will all come away. That's the plan. And stay attached. Best laid plans and all that sort of stuff. And in fact, I am going to do it to the washer as well. I don't want that moving and coming off either. But the nice thing is about silicone adhesive, or the sealant, I'm going to get it all over my fingers, it's inevitable, is that you can take it off again, it just peels off, so it doesn't give a permanent bond. So the washer's glued to the prop, and then the nut will glue to the washer, sort of. All over my hands as usual. So let's just check that we're on the trailing edges again. We are. This doesn't need to be done more than finger tight. And then I'm going to put the spinner on just to make sure all the holes and everything line up. And the arrow's over there, like that. And the screws are lining up indeed. So the model fixings has come through this morning with a bag of 100 of these little M2 by 6mm long. And what I'm going to do is I'm going to fit them in their black state, and then I'm just going to touch the heads in with paint. If you spray them first, the driver, the Allen driver, could easily take the paint off, so you may as well start with them black and then just touch the heads in with a bit of red paint. So that's exactly what I'm going to do. So we'll just let this dry for probably most of today. Probably leave it till tomorrow, to be honest. And the silicone should be really well set then. And then we can unscrew that prop adapter, and hopefully it'll leave the nut inside. And then when we want to use the static prop, we just expose the shaft on the model by taking the proper flying prop off and spinner and everything. And then we just thread this whole assembly straight onto the shaft for static judging, and then we can whip it off again quite quickly once they're finished. So this more or less completes the static prop. You obviously don't need a static prop if you're not going to compete, but they're not difficult to make and they're quite good fun. So there we go. So I'll just touch these in with some red, and then we'll get a photograph at the end of that, and we're more or less done.